what I'd like to explain here is a little bit about zener diodes, and more specifically their impedance. Impedance is just a measure of resistance to current flow. Zener diodes they function in the reverse direction, and once they've made it past the knee voltage, they have a relatively linear relationship between voltage and current, meaning that we can calculate a impedance for them. Starting here, if we picked up a zener diode in its data sheet, you would have the voltage Z knee. That's the voltage that it's going to regulate at the base current. Looking back a couple of videos, that's the point where in the reverse bias it turns and small voltage changes get us big current changes. And just to make up some numbers here, let's pick 10 volts and say that's what it's going to regulate at as a minimum at that knee. And it's going to do that at 3 milliamps. Okay, and then you'd have two other voltages listed. There'd be VZ. This is its rated voltage, and I don't know, this could be 10.8, and that would be at some higher current value. For the sake of this video, let's call it 40 milliamps. And then lastly, the third voltage you'd get would be ZVM, which refers to max. So this is the maximum voltage and current that it can handle before it destroys itself. And this might be, I don't know, 11.2. And again, it's relatively linear between all of these. I'm not sure these numbers are all that linear, but I think you get the idea. It might be at, I don't know, 60 milliamps. Right? So, you know, if I were to draw it out in that graph, like in a previous video, what we're talking about is this point where it turns. You know, this is the 10, 10.8, 11.2. So you can see, and then these are the, you know, matching currents over here. Again, that's a review from a previous video. If I wanted to know what the impedance for this was, say between the knee voltage and the rated voltage, what I'd be looking for is Ohm's law, the change in voltage over the change in current. Right? Ohm's law. So, if I'm looking for the change in voltage between the knee and the rated, I want to say, what's the voltage rated, and how much has it changed for the voltage at the knee? Right? So that's the change in voltage between the knee and the rated. And on this side, of course, we'd have the current that's being drawn at the rated voltage and the current that's being drawn at the knee. Again, remember, the knee is this point right here. And that would be the knee current. In our circuit, that means we're looking at, I'm sure you're hearing that bird, I apologize. That means we're looking at 10.8. If anybody's a hunter, they could help me out on this one. 10.8 volts minus 10 volts divided by 40 milliamps minus 3 milliamps. What that means is, here we're going to have 0.8 volts divided by 0.037 or 37 milliamps, which means this zener diode has an impedance within that range, between the knee and the rated, of 21.62 ohms. That number there we will use in calculations later on when we're trying to solve these circuits and figure out how much current's flowing and where it's flowing.